Okay, ladies and gentlemen, welcome to 18.2, air pollution. Okay, so this is where we're going to take something that's very broad and not specific and try and make it more detailed and give you terms that you guys can use on FRQs, etc. Because by its definition, I picked up in the book, air pollution is any chemical, particulate, or substance, which chemical, particulate, and substance, none of them are specific enough to be useful to you, that remains in the atmosphere for a long enough period of time, long enough duration, to become harmful to organic tissues and organisms. So harmful, vague term, duration, how long, and so now we're trying to get a little bit more specific with all of these things, okay? So air pollution sources. First off, we have to make note that air pollution can be natural. Alright, so think about volcanoes. They could be spewing out sulfur compounds, nitrogen compounds, carbon monoxide, carbon dioxide, hydrogen compounds, volatile organic compounds, all those different things. Wildfires are going to produce lots of carbon dioxide and particulates during the combustion of the trees. Plus, once the trees are destroyed, they can no longer sequester carbon dioxide out of the atmosphere, which leads more into the atmosphere to exacerbate climate change. And then, of course, decay in marshes and bogs, right? So these things, since usually they're very swampy, wet conditions, right? The water doesn't have oxygen in there, and decomposition without the presence of oxygen is anaerobic, and instead of forming carbon dioxide, it forms methane. So we get a lot of methane production in these areas. Anthropogenic, if you haven't heard that term, have to know this. Anthropogenic means human caused, human induced. So of course human causes air pollution. A lot of it is burning of fossil fuels, oil, coal, gasoline, straight for our cars, for power plants, a lot of the industrial products that we make, the chemicals that come out of these petroleum-based products make plastics, industrial solvents, but we'll get to some more specifics in just a bit. Our major categories of air pollution, of course, we've got carbon dioxide, CO, carbon monoxide. We have a slew of nitrogen-based compounds, right, and a slew of sulfur-based compounds. And the beautiful thing about the AP test, AP environmental test, is that you do not need to know the difference between any of these nitrogen-based compounds, nor do you have to know the difference between any of these sulfur-based compounds. All the nitrogen-based compounds can simply be referred to as NOx, right? NO subscript X. And the sulfur compounds can simply be known as SOx. That should be uppercase O, sorry. So that's it. All nitrogen-based compounds produced from anthropogenic sources, and even natural sources, can just be NOx. Sulfur-based can be SOx. Done deal. You can write that on an exam, you can put that in an FRQ, and a lot of times that is the option given to you in a multiple choice question. And then of course the CFCs, which we generally associate with ozone depletion, which we'll talk a little bit about in a little while. They can also be a pollutant. So let's move on. Categories of air pollutants, we have two, primary and secondary. So primary sources of pollution are the ones that are emitted directly into the air, right? So as soon as maybe you burn some gasoline and you have some NOx or nitrogen-based compounds that are released, they go right into the atmosphere. That is a primary pollutant. Then that NOx or SOx may react with something, a natural component of the environment, typically that's water. When it reacts with that, and that NOx forms a new compound, maybe nitric acid, to fall back to us as acid rain, now that is a secondary pollutant, okay? So some primary pollutants. Carbon dioxide. Again, what are the sources of these? One, from combustion, fossil fuels, also from, number two, fires, okay? All of these things, like the fires can reduce our forests and grasslands, plus we may cut them down to build for agricultural purposes. Remember, why is that then going to exacerbate air pollution? Once we remove those trees, they can no longer sequester carbon dioxide out of the atmosphere. Therefore, there's more left in the atmosphere to exacerbate climate change. NOx. Typically, we see these. There's other sources of NOx from human causes, but the main ones, vehicle exhaust from the burning of gasoline. Okay, so start this. most of the time, 90% of the time when they're asking you a question about NOx and where it's from, the answer should be vehicle exhaust from the burning of gasoline. And then SOx, a third of it comes from natural sources, volcanoes, but the big bulk, the chunk of it, comes from the burning of coal at power plants. Coal is high in sulfur. So when we burn it, we release those sulfur compounds into the atmosphere. So star the second bullet. 2/3 of the sulfur comes from the burning of coal at power plants. And some comes from diesel. So prior to 2006, diesel fuel had a lot of sulfur in it. Now, after 2006, they mandated that all diesel fuel had a certain level of sulfur in it. I mean, and it was much lower than what was that previous standard. So they had to refine the diesel some more to create what's called low sulfur diesel. And if you ever pull up to a gas pump and you say there's gasoline, all right, and it always says unleaded gasoline, if you look at the diesel, you'll probably see that it says low sulfur content or low sulfur diesel. Okay, so now these same three categories then form secondary pollutants. So carbon dioxide, right, of course, doesn't get absorbed by forest grasslands. Increased temperature of the atmosphere contributes to climate change. Okay, so that's the important stuff about carbon dioxide. Now let's look at NOx. The NOx goes into the atmosphere. It reacts with water vapor that's already present in the atmosphere, and it forms nitric acid and nitrate salts. Okay, so the nitric acid can become a component of photochemical smog. More on that later. And the nitric acid, which once it mixes with rain, right, can come back to us as wet acid deposition. And these nitrate salts can fall back down because they're like particles now in the atmosphere. They can fall down to us as dry acid deposition. SOx, again, will combine with water in the atmosphere, and it will form a couple things. So it says aerosols here, but I also want you to write sulfuric acid next to SOx. So we'll mix with water, form sulfuric acid, all right, and sulfate salts. So you got sulfuric acid, which can come to us in the form of wet deposition, and sulfuric salts, or sulfate salts, that can come back to us in the form of dry acid deposition. Okay? Now, SOx is usually thrown into a very broad category as a secondary pollutant known as aerosols. Aerosols is a generic term that you can use in an FRQ. As long as you use it right, you can use that term. But basically, an aerosol is anything that is a liquid droplet or a small particle that is in the atmosphere. So for example, fog could be termed an aerosol. It's a liquid component that hovers and hangs in the atmosphere and that can descend back upon the earth. And SOx is usually associated with aerosols in the atmosphere. Because it comes a lot, mostly from the burning of of coal. When you burn coal, you produce a lot of particulates. They go in the atmosphere together and they form these suspended particles. Some of them termed aerosols. There's another term for them we'll see in a second. So, other major outdoor air pollutants. SPM, suspended particulate matter. Go right back to those aerosols. Aerosols are a suspended particulate matter. Okay, so these things can be solid particles or liquid droplets. That's the definition of an aerosol. 62%, look at that, come from natural sources. So again, a lot of air pollution does come from natural sources. So dust, sea salt, wildfires, volcanoes. 38% is man-made, with the bulk coming from coal. Right? Coal, again, is very dirty. And the coal we use in the United States is a much cleaner version than some of the rest of the world. But China, huge country, bring lots of coal. All of the particulates that they put in the atmosphere via diffusion spread around the world eventually, right? It doesn't just stay there in China. Eventually it will rise, disperse, and be everywhere. Some of these small particles, right? Because your nose filters out, the hairs in your nose filters out some of the particles. The mucus lining in your throat filters out some of them, but some of the bigger ones, the ultrafine small particles get deep down into your lung tissue, where it cuts up, creates scar tissue, and can eventually lead to lung cancer. In the United States, it's estimated that the suspended particulate matter that is in our air caused the premature death of 60,000 to 70,000 people in the U.S. All right, so these, of course, are usually children who have very harsh asthmatic conditions, older people who suffer from emphysema, asthma, and some other lung issues that it's not coming to my brain, but still 60 to 70,000 premature deaths in the United States from suspended particulate matter. Now contrast that, however, with China. That's what we're always comparing ourselves to, is US and China. They have an estimated 1 million premature deaths from suspended particulate matter every single year. 1 million. That's crazy. But go look at some pictures online. Google image right now. Pause me here. Go type in Beijing smog and look at some of the pictures. Crazy. I know I mentioned it in a previous recording, but there was a fire last year in Beijing, in that city, that burned for 3 hours before anyone noticed that the building was on fire, because no one could decipher the smoke from the fire from the smog that's always present. Okay, ozone. Ozone, the ozone you know and probably think of in the stratosphere is good. However, ozone in the troposphere as a product of industrialization is a bad thing, right? We don't like it. So it's a product of photochemical smog. More on that, it's photochemical smog in a second. All right, but basically there's a reaction with our NOx and UV light. One of the products is ozone. All right, when you breathe it in, it is an irritant. It's called bad ozone. Good up high, bad nearby. Tropospheric ozone, which is troposphere is where we live. That ozone is bad for us, not just us, but for all living tissues. It damages tissues because ozone is O3, right? O3 is not a stable molecule, and it likes to break apart, right? You get O2 and then a single atom of oxygen, and oxygen doesn't like to exist as a single atom, all right? And it wants to steal electrons from things to become more like a noble gas and slightly more stable. Right, so to satisfy the octet rule, it's going to try and steal some electrons. And to do that, it steals them from the living tissues that it comes in contact with. And that is how it degrades and breaks down these living tissues. So we are increasing bad ozone from our industrial processes, decreasing good ozone, again, through some of the chemicals we release, more on that later, that has diminished the good ozone layer in the stratosphere. Volatile organic compounds, VOCs. The main thing to know about this one right here is usually hydrocarbons. All right, so long chains of carbon and hydrogen. All right, all of those things are VOCs. So CH4, methane, that's a volatile organic compound produced naturally. All right. Also, any of the petroleum-based chemicals that we produce for industry, in the production of our plastics, right? Plastic is a petroleum-based product. So in the production of these things, we release these volatile organic compounds. And the volatile portion of that means, like take gasoline for example. Gasoline, you know when you're pumping it and you see those fumes coming off? Those are VOCs, volatile organic compounds. It means it wants to go into a gaseous state very, very quickly. All right, so it escapes as a gas into the atmosphere, and then we breathe them in. When you open up a can of paint, right, and you get that very pungent, smack you in the face smell, that's because of the VOCs that are present in there, because we use a lot of petroleum-based products to make the paint that you're using. That new car smell that we love so much, those are all VOCs, volatile organic compounds, right? Because you got all that plastic trim and petroleum-based carpet that's in there, and it's off-gassing, right, and making these VOCs that we then breathe in. Benzene, found in emissions in cigarettes, unfortunately can cause leukemia and blood disorders, so don't be smoking no cigarettes. And of course, since it's found in our emissions, we're putting it into the atmosphere. That sucks. Yeah, good times, good times. So what is smog? Here's a lovely picture of smog. Named by this guy, I don't know, probably a Frenchman. Maybe he was from London, I don't know. Describing the air in London in 1905. He combined the terms smoke and fog, smog. Today it's recognized as a type of air pollution. Then it was caused from the burning of coal in the London area. And in the 1905, I think they lost 4,000 people due to a very bad season where there was a temperature inversion. Talk more about that later. And basically what happened in this temperature inversion is that it kept the smog over London, and they had lots and lots of deaths. So we're going to look at now industrial and photochemical. Okay, so what you need to know about industrial smog, right? You got to know what's the main component of this, right? So we've got SOx, sulfur-based compounds, all right? So from the burning of what? Coal power plants. So industrial smog, the main component is SOx. We know SOx is always associated with coal from power plants. SOx, we know a secondary pollutant would be sulfuric acid, ammonium sulfate. Sulfuric acid, the most important of the secondary components, called gray air smog. You can see a picture that looks kind of gray. What country would suffer the most? Now, before we think of anything else, we know it comes from the burning of coal. What country burns more coal per capita than anyone else? That would be China. So, what country suffers the most? China. China's number one. And then India as well. Again, another very large country. A lot of people to produce energy for, so they do use a lot of coal as well. And then we've got Ukraine on here. But if you remember nothing else, no other country, you see SOx. You think coal, you think China. All right. So industrial smoke or smog, SOx, coal, China. Boom, got it. Photochemical smog. All right, the major component is our NOx. So you see NOx, and it has VOCs on there. Remember that, that's important too. But if you remember only one of them for photochemical, remember NOx. So you think NOx, you know NOx comes from the burning of gasoline in fuel. Okay, so photochemical smog, we need sunlight to react with the NOx to form the photochemical smog. Secondary component of it is ozone. When the ozone reacts with the NOx, a byproduct of that is ozone. Trucks, and this stuff is brown. Cars and trucks, brown. Good? Lovely. Factors decreasing air pollution. Okay, so heavy particles settle out and fall to the ground. Okay, so some of these salts, the nitrate and the sulfate salts, settle out if they form these bigger particles. So that's good to a degree because it gets out of the air, but eventually ends up on the ground. Rain and snow, after a good rainstorm or a precipitation event of any kind, right? That's falling precipitation combines with a lot of the stuff that's in the atmosphere and brings it down and clears out the air. Sea spray, as the polluted, horrible term, pollution, right, vague, as it moves from land over the ocean, the crashing of the waves, right, puts sea spray and sea salt into the atmosphere, combining with some of the air pollutants and then dragging them down into the ocean. Wind can help sweep some of this stuff away, right? So China, right, what they'll do is if there's going to be a big event taking place there, they'll stop the burning of, stop transportation, stop burning coal, and let the wind sweep it out to clear out the air before some important diplomat or some event takes place there. So gases combine, create droplets, and can wash out of the atmosphere. Right, so secondary pollutants, right, they become heavier and they fall faster. Factors increasing air pollution. Urban building slows wind and reduces the dilution of the toxins, another vague term, in the atmosphere. Hills and mountains. If you're a city surrounded by mountains, right, you may not get that breeze that would wash out or remove those toxins, right, because you're blocked. That wind is blocked from the mountains. High temperatures promote the chemical reactions, right? So as these primary pollutants are in the atmosphere, right, as soon as the sun starts to beat down on them, right, you can actually see an increase in photochemical and industrial smog throughout the course of the day. Right, it gets smoggier and smoggier because those primary pollutants are reacting with the sunlight and the water vapor to then produce the secondary pollutants that color the air. VOCs, volatile organic compounds, which some of them can be natural from plants such as oak, sweet gum, and kudzu. Yeah, that's crazy. And the grasshopper effect, air pollutants transported via winds to different locations, going back to China. The more air pollution they make, the more polluted our air becomes, because the wind will eventually move it away from China, and then it'll become dispersed throughout the globe until it reaches a balance and is equally dispersed everywhere. Right? So the more China pollutes, the more our air becomes polluted. And then temperature inversions. So usually you have cool air in the morning, right? And as the sun beats down, it's going to heat up and it's going to rise. And it's going to right? Hopefully, towards the end of the day, right, it would carry a lot of that warm air would move up with those pollutants and hopefully carry it out. So towards the end of the day, it's less polluted. Okay. Well, if there is, say you're located near the sea and there happens to be a warm air breeze coming from the ocean, right, and it comes over the top of that cooler air inside the city, right, well, now that warm air rises up, it hits that cold air above it, and it can no longer rise, so it just stays stuck there. And sometimes over in California and some of these valley cities, they may have a temperature inversion that lasts several days, so they have a buildup of these pollutants, air pollutants, and they get trapped in there underneath this blanket of warm air, right? So that's no good. And that is the end of 18.2. That was a long one. I know it was a mouthful. I apologize.